Hello and welcome to the VPhase training video. I'm Dave Austin from Learning Lounge.
And I'm Andy Rigby from VPhase.
We'll aim to outline the principles behind the VPhase technology, undertake a live installation and have a Q&A session at the end. And before wrapping up, we'll tell you more about the great support you can get from the team at VPhase. Voltage optimization is not actually a new technology. It's been widely accepted and used in the commercial sector for many years, saving millions of pounds for big businesses. Companies like Tesco, Asda, the NHS and many others use commercial voltage optimization devices in their buildings to make significant savings. Unfortunately, commercial voltage optimization units are about the same size as a fridge freezer and can cost thousands of pounds. Not a very attractive proposition for a home.
So what VPhase have done is taken that proven technology and miniaturised it, reducing both the size and the cost of the device so it's suitable for domestic installations. But before we get on to the specifics of VPhase, it's probably best to outline why the technology is important.
In the UK, although the supply voltage is 230 volts, it does have a tolerance of plus 10% or minus 6%, so it can be anywhere between 216.2 and 253 volts. And inevitably, as we can see if I use this test instrument, it's usually higher than 230 volts. And it is here.
However, since the early 90s, harmonisation with Europe has meant that all appliances sold in the UK must work across the EU range of voltage, which is as high as 253 volts or as low as 207 volts.
Therefore, the majority of appliances and devices in consumer homes are being supplied with excess voltage they simply do not need. Now, I think at this stage it's important to note that the VPhase device is designed to work primarily on a single-phase domestic supply. But there are situations where individual VPhase units can be applied to individual or multiple phases of a three-phase supply if the installer wants to select the circuits that are being optimised. More on this later though. Right now, let's find out a bit more about the device and why we should bother using voltage optimisation.
The question about why bother optimising is often asked, and it's something we touched on earlier. With the typical voltage supply in the UK being at the higher end of the statutory scale, domestic properties are being supplied with much more voltage than they actually need. This is wasted energy and wasted money.
How much can be saved depends on the energy profile of the property the VPhase is installed in, how many people live there, and what sort of appliances are in use. It may surprise some people to know that over 67% of a domestic property's electrical consumption comes from lighting and appliances, whereas a common misconception is that it's the electrical heating circuits in a house that are responsible for the largest proportion of energy usage, but this simply isn't true.
Yes, the electrical heating circuits may draw a lot of power, but they're typically on for a relatively short period of time. For example, boiling a kettle or having a shower, as opposed to a fridge or freezer that's on day in, day out. A further benefit of VPhase voltage optimisation is that it should actually extend the life of appliances too. Work has been carried out with the Lighting Industry Federation that demonstrated how optimising the voltage to the default VPhase output level of 220 volts can extend the operating life of lamps. But before I get into the nitty-gritty of the technical side of things, I think it's important to let you know we're not just blowing our own trumpet how good the device is.
The VPhase voltage optimisation device has won a range of awards from the likes of the Electrical Times, Shell Springboard and Professional Electrician and Installer.
It may sound like we're showing off, but we think it's important to let everyone know that this is a robustly tested, independently assessed device that has been proven to achieve the claims we make.
So Andy, how does the VPhase actually work?
Well, imagine a pair of noise-cancelling headphones. By producing a low frequency wave that cancels out the background noise, well, that's the same principle behind VPhase. The device generates an anti-phase sine wave that lowers the level of the incoming voltage sine wave. And the VPhase has a wide operating range too, as we know that voltage typically fluctuates throughout the day, depending on the demands of the supply network. The technology inside the VPhase detects the incoming voltage approximately 24,000 times per second, and then the AC to AC power converter adjusts accordingly so that we can provide a constant output voltage to the main fixed transformer in the device. This is important because it allows us to control the output voltage from the VPhase, which is where the optimisation comes in. We're not just chopping the voltage, we're optimising it too and smoothing it out so that it's a constant supply. In order to get the most from the VPhase, we've also included some specific jumper settings on the PCB that can be used in instances where the incoming voltage may be slightly below the UK average. These settings are in 5-volt increments from 210 volts to 230 volts and can be set by the electrician at the point of install.
So we've established how the VPhase works by optimising the voltage and quality of supply to your electrical equipment. But what are the savings?
Well, we've gone to great lengths to have the VPhase device independently tested so that we can confidently state what the savings range should be. In the trials we've undertaken, savings have ranged from around 6 up to 12%, with the majority of results grouping around the 10% mark.
Some devices and appliances save more than others. For instance, a typical A-rated fridge freezer is still quite inefficient, primarily due to the motor powering it. Supplying it with an optimised level of voltage from the VPhase unit has been demonstrated to save around 17% in most cases. Similarly, incandescent light bulbs, 15%, energy-saving compact fluorescents, 10%, LCD TVs, around 4%, a cordless phone station, 30%, and there's a full list of devices on our website. It's clear to see from these back-to-back testing graphs, where the top line shows energy consumption over time with unoptimised voltage, and the lower line shows the effect of optimising the voltage with VPhase. The appliances simply use less energy, and therefore save the homeowner money. In this part of the video, we're going to install the VPhase unit into this consumer unit. Now, not every consumer unit is the same, and many won't be as current as this one, but there are a number of configuration diagrams supplied in the installation guide that can be referred to. So what's the first thing to do, Andy?
Well, the first thing to mention is, of course, that the installation of a VPhase is notifiable under building control. I'm going to be using the 8-step installation guide available from our website, and the first step is the site survey to determine the best location for the VPhase. Looking at this installation, there is plenty of space around the consumer unit, so I'll install the VPhase above it. Step 2 is to determine which circuits can be optimised. Looking at the circuits here, we would recommend optimising all of the circuits except for the cooker and the water heater ones. These are resistive circuits which cannot make savings with voltage optimisation.
So now we've identified the circuits, we can do step 3, which is to locate the VPhase on a suitable surface and secure appropriately. Okay, Andy's fixed the VPhase into position, so now we can move on to step 4. We've switched off the installation and checked for dead, and because we're in complete control of this installation, we won't be locking off on this occasion. So now it's time to install the supply cabling.
Here it's important to point out that I'm not going to be connecting directly to the meter tails, but supplying the VPhase through a 50 amp MCB, which I'll position next to the main switch. Here I'm going to be installing a 10mm squared twin and earth cable to supply the VPhase unit. Now for step 5, we need to reconfigure the board to accommodate the 50 amp breaker and arrange the optimised and non-optimised circuits.
It's good practice here to make sure that neutral and CPCs are also adjusted to the appropriate terminal in the board.
All final connections are now made across the consumer unit and the VPhase. The main switch supplies a 50 amp MCB and RCD1. The 50 amp MCB with a 10mm cable supplies VPhase and VPhase supplies RCD2. RCD1 is controlling the cooker and water heater circuits, the resistive loads that make no energy savings. RCD2 is supplied from VPhase. RCD2 would then supply the sockets, lights and garage circuits. However, usually we would have RCD1 and RCD2 separating lighting and socket circuits. Effectively, we have a three-way split as we've installed an RCBO which is fed still from VPhase to maintain some lighting circuits in the event of RCD2 tripping.
Now that Andy's installed the unit and reconfigured the circuit breakers, it's essential to carry out step 6, which is the necessary dead test before the supply can be re-energised. The tests are only undertaken on what Andy has installed, and we'll start with continuity of protective conductors and polarity before moving on to insulation resistance tests.
Whilst carrying out insulation resistance testing, due to electronic components within VPhase, we recommend that the unit is disconnected from the circuit whilst carrying out these tests.
When the testing is complete, we have step 7. The covers can be replaced and the supply re-energised to allow for live testing and certification.
Once the unit is energised, the green LED will illuminate. The red LED will flash for 15 times, approximately 30 seconds. The unit is carrying out a self-test. Once this is complete, the unit will then move into optimisation. I've completed the testing, relabelled the consumer unit, and will issue an appropriate certificate for the work I've done today. Now it's time to verify that the VPhase actually does what it's supposed to.
So using the same socket as before, I'll plug in my tester and we get a voltage of exactly 220 volts. So Andy, what sort of support can the average electrician expect?
Well, first of all, we have a first-class website that has tons of information on it. There's a unique savings calculator that can be used with customers, and this is also available as a free iPhone app too. We have a Find an Electrician feature on the website, so any electrician can be registered and searchable by potential customers. And importantly, we have a fitters forum where technical information can be downloaded or questions asked directly to our in-house tech team.
And is there any other technical support available?
Yes, there certainly is. We have a dedicated technical helpline where electricians can call up during office hours and get live one-to-one help from trained electricians. We get asked all sorts of questions, but there's generally nothing we haven't had to deal with before, and most of it's covered on our website anyway. But we're here to help.
Well, that all sounds pretty comprehensive, and we should cover the majority of the main points in this video as well. Is there anything else available?
Well, we have regional training seminars that take place around the country throughout the year. They're free of charge to attend and normally include pretty much what you'll see on this video, plus the opportunity to have a Q&A session and perhaps more importantly, understand how to sell the VPhase to customers in an informed way. Our marketing team help with that too and can provide customised marketing leaflets and flyers so that electricians can promote the fact that they're VPhase installers. I think it's important to stress that you don't actually need any specialist training to install the VPhase though. Any Part P qualified electrician can install one. We're just here to help with the more commercial side of things and to provide guidance and advice.
That's great, Andy. Now, I know you said earlier about the testing that you guys have carried out, but electricians tend to want to know a bit more about this. So what sort of trials have been completed?
I completely understand, Dave, which is why we've included all the trial information on our website. This ranges from social housing trials with Great Places Housing Group, which has now resulted in the VPhase being specified in rewires and new builds in the group, to staff home trials, work with Scottish and Southern Energy on a zero carbon housing project, and the Ofgem approved CERT demonstration action. We've taken great care when we carry out trials to have the data independently analysed, to measure the savings, and that's why we're so confident in promoting our product. We also have stands at a range of exhibitions, including all the elect shows. We work closely with the electrical distributors and wholesalers too, so we're often on hand at trade days that they run as well.
All sounds good to me. Perhaps it's time now to have a little Q&A session though. I'm sure that when you're running these trade days and your own training sessions, you must get asked all sorts of questions. So one of the obvious questions has to be, what happens with the current when a VPhase is installed?
This is a very common question, and the easy answer is that the equipment will still draw the current that it needs to operate. The common misconception is that if the voltage drops, that the current will change by an equal proportion. However, let's use the basic power formula to demonstrate what happens. So we have power equals V squared over R. Let's start with a voltage of 245 volts and an electrical appliance resistance of 100 ohms. So we have 245 volts squared, which is 60,025, divided by 100, which is 600 watts. Let's now look at the same equation with the optimised voltage of 220 volts. We have 220 volts squared, which is 48,400, divided by 100, which is 484 watts. If we now divide each of the wattages by the voltage, we get the current being used in each case. So for the 245 volts, we get 2.4 amps, and for the 220 volts, we get 2.2 amps. So even though the voltage was reduced by 25 volts, the current was only reduced by 0.2 of an amp. So despite the negligible reduction in current, the key thing to remember is that the wattage is reduced, and that is what your electricity bill charges are based on.
There's a huge amount of interest right now in solar PV. Does VPhase work with that?
Yes, VPhase device works alongside solar PV installations, optimising the power drawn from the grid and maximising the potential savings from the system.
But can it optimise the power straight from the solar PV and the inverter?
No, it can't do this. There's a legislation, G83/1, that states that the solar system must be able to see the grid. So in case an engineer is working on the line, the solar system must know that it can't send power back to the grid, so the inverter can't go through the VPhase. To install alongside solar PV, the VPhase needs to be kept separate from the circuit breaker for the PV system, in the same way that we've kept the resistive circuits separate in this board.
So how long is the VPhase unit going to last?
Well, we've had the device independently tested at a component level and across a range of applications and temperatures. It has been projected to have a lifespan in excess of 25 years. Many of the calculations actually showed it to be in excess of 35 years.
And does it come with a warranty?
Oh, absolutely. We provide a 5-year manufacturer's warranty with the device, which, when you think that payback periods typically fall within a 3 to 5 year time frame, means it's virtually a risk-free investment for consumers.
We've obviously covered a fairly standard installation today, but are there any restrictions as to whether VPhase can be sited?
Within reason, and obviously taking into account that the device isn't weatherproofed, the VPhase can be installed anywhere you can run the cables to, obviously allowing for voltage drop. It doesn't necessarily have to go above or below a consumer unit. It can be on an adjacent wall or even sited on the other side of the wall if space is tight. We've even had some cases where electricians have installed the VPhase in the attic space.
And is the VPhase suitable for all types of properties?
Yes, it's pretty much a universal voltage optimisation device for domestic properties. We do get asked the question about whether the VPhase can be used in small commercial and industrial buildings, and the answer is that it really depends on what sort of loads they're going to have to deal with. The VPhase is designed for constant operation at 2 kilowatts and a short duration of up to 4.5 kilowatts. If this is exceeded, the VPhase will gradually increase the voltage up to the supply level to accommodate a larger load. Once the load is removed, the VPhase gradually ramps down back to 220 volts.
And I'm sure you must get asked this all the time, what the VPhase can and can't be used with. For example, why can't it be used with resistive heating?
We specify in our installation manual and on our website that no savings can be achieved by optimising the voltage that supplies the resistive heating circuits. This includes electric cookers, electric showers and immersion heaters. The reason being that if you put less power into a resistive heating circuit, you'll get less heat out. So any savings you may make from reducing the power are lost as the devices and appliances have to be on longer to reach the desired temperature.
And what about LED lighting?
Well, every LED fitting may be of different construction, but with VPhase tests we've seen savings demonstrated of up to 17%.
And what about underfloor heating?
Unless it's a wet type system utilising a pump where savings can be made, the most common type is a resistive load. For a dedicated circuit, this can be excluded, as in our installation today. However, for retrofits, these are occasionally run off a ring circuit. In this situation, it's fine to optimise a circuit, meaning that savings will be made on other loads, but not on the underfloor heating.
And what about solar thermal?
Well, these utilise a pump, so savings will be made.
And heat pumps?
Well, if the pump rating does not exceed the VPhase upper limits, then savings of between 15 and 18% can be achieved.
What about small commercial businesses?
Well, again, if the circuit loads are within the tolerances of VPhase, then savings can be made. So smaller commercial installations, such as small offices and small retail outlets, can clearly take advantage of the VPhase system.
And what about fitting the VPhase to 16th edition fuse boards?
As long as the electrician has made an assessment of the general characteristics of the installation, there is no reason why the VPhase cannot be installed and the board configured as required for the optimised and non-optimised circuits. There is certainly no requirement to upgrade the existing installation to the 17th edition.
And last but not least, the most important question, where can I get one?
Well, the VPhase is available from all the major electrical distributors and wholesalers and many of the regional independents too. A full list is available on our website.
Well, that's been a comprehensive look at VPhase voltage optimization. I hope you found it as interesting as I did. For further information, there's the website www.vphase.co.uk with a fitters forum for technical inquiries. But you can also reach us on the technical helpline and find us on Facebook, Twitter and YouTube. See you soon.
And thanks for watching.